GITAI is a Japanese space startup founded in 2016 with a vision of disrupting the space industry by providing in-space construction and maintenance services. From concept to prototype to flight models on the International Space Station, GITAI has been maturing and perfecting its technology systems just in time for the explosion in the ISAM market, that is the in-space assembly and manufacturing sector that is attracting more and more interest from space agencies and venture capital from investors. GITAI embraces a culture of experimentation, which can be seen by the many YouTube videos on their website covering the tasks, operations and testing of their robotic systems. Their trial and error approach to developing space technology has been successful, with a flight-proven robotic arm successfully demonstrated on the International Space Station. It's not quite at the level of the Canadarm, but it's still an impressive piece of engineering, demonstrating that GITAI is one of the top space robotic arm companies in the world. The company plans to reduce the cost of labour in space by 100 times, making assembly and construction of systems and platforms in space affordable. GITAI has secured orders from JAXA, that's the Japanese Space Agency, and the Japanese government, and are working with Toyota on the Lunar Cruiser, part of Japan's contribution to the Artemis program. This will be a pressurized lunar rover capable of traveling 20 kilometers in a single day while carrying 2 crew. GITAI's contribution to the Lunar Cruiser will be a robotic arm for uncrewed missions or to assist crew with tasks. The Lunar Cruiser is expected to launch to the moon in the mid-2030s. In 2023, GITAI shifted their headquarters from Tokyo, Japan to Torrance in the US. Shortly afterwards, they were selected by DARPA to contribute to the Lunar 10 architecture study. We will look at the 2 major areas GITAI is working on. 1. On-orbit services, and 2. Lunar infrastructure construction. Before we look at those 2 areas, let's first look into the claim that GITAI can reduce the cost of labour by a factor of 100. Robots versus astronauts. How much does it cost to put an astronaut into space for the purposes of construction, maintenance, upgrade or repair? The figure bandied about is $100,000 per hour. Is that true? Well, in the case of NASA astronauts, they are federal workers earning between $50 to $77 an hour, but that ignores the massive infrastructure cost of getting them into orbit. So, what is the total marginal cost to NASA for launching an astronaut into space for a servicing mission? Well, NASA gives us their official rate for ISS crew time. It's $130,000 per hour. That is a reimbursable fee charged to commercial partners for an astronaut's dedicated time on private activities on board the ISS. So, assuming NASA's added some padding to its official rate, a figure of $100,000 per hour of astronauts' time is fair. This backs up GITAI's claim that their robotic arm could drop the cost of servicing missions by a factor of 100. Astronauts' time is extremely expensive, and that's before we factor in the safety of operating in space outside a station. A tiny piece of orbital debris hitting an astronaut while outside a station would be disastrous. Robots are not only cheaper, but safer, and don't require rest, sleep, food, or all the other requirements needed to keep astronauts alive. Okay, let's now look at their Inchworm robot. Once you see how it works, you'll understand why it's called that. GITAI designed the Inchworm robot for use on space stations and satellites. The arm is packed with features that make it a useful tool for a wide range of tasks in microgravity environments. Its basic function is to support maintenance and repair tasks, in addition to aiding with scientific experiments in space. The robotic arm, called GITAI S2, has been successfully demonstrated on the ISS and has achieved a TRL 7 level. This is a NASA scale that goes from 1 to 9. TRL 7 means full-scale prototype in commercial conditions, meaning the robotic arm is ready for commercial operations. The company can provide robotic arms for low Earth orbit missions or lunar applications. Their robotic arms work under Earth gravity, which the company considers important as it means they can do extensive testing on the ground. This robustness means that their robotic arms can easily work under microgravity conditions or the 1/6 gravity on the moon's surface. The robotic arm is capable of autonomy with a built-in camera and sensors. The end effector can be changed for different tasks. It has an interface on both ends that allows for the arm to move around a surface that has interface adapters. It has a 5 kilo payload capacity, so can only handle lightweight structures at the moment. The arm itself is 2 meters long with 7 degrees of freedom, providing ample reach and flexibility for a wide range of tasks. It's possible at any time to take control of the robotic arm and use it as a teleoperated arm instead. GITAI considers this dual mode to be a practical approach to building a moon base. On-orbit services. GITAI envisions their robotic arm will be used for life extension and orbital debris missions. Space is, unfortunately, littered with derelict and defunct satellites and upper stages. The situation continues to get worse with each passing year. As mentioned at the beginning of the video, ISAM, or In-Space Assembly and Manufacturing sector, is receiving more interest from space agencies and investors. GITAI is well positioned to exploit this market with a capable robotic arm system. Future commercial space stations will benefit from robotic arms to upgrade the station or position and place external scientific experiments. Large structures needed for space-based solar power will need to be assembled in space. And, as mentioned recently on this channel, large gigawatt data centers in space will require assembly using robotic systems given their scale. It's likely that military platforms in space will be keen to use robotic systems as well. Let's now turn to the moon. Lunar Robot. GITAI is working on a lunar rover called R1. It's a general-purpose robotic rover that can perform exploration tasks, but in addition, thanks to its robotic arms, it can also perform inspection, maintenance and assembly tasks. The rover has been tested in a mock lunar surface environment and successfully completed a number of planned tasks. All the key components of this rover and all robotic components used by GITAI have been internally developed. This includes motors, autonomous control and teleoperation systems. Its dual arm manipulation system is capable of performing intricate tasks that other simpler systems would not be able to perform. Lunar infrastructure construction. Robots and rovers will play a big role in building a moon base. From habitats to landing pads and critical infrastructure, robots operating autonomously or being teleoperated will be essential. Rovers are great for logistics, picking up and carrying cargo from landers to a habitat or storage areas, from hauling a regolith from mining to processing sites. Rovers are also needed for assembly tasks and for precise placing of equipment and assets. The more a rover or robot does, the less an astronaut needs to do, and the quicker a base can be established, maintained and upgraded. In addition to assembly, GITAI robotic rovers could do disassembly. For instance, scrapping a defunct lander or scientific payload and transporting the scrap metal to a metal foundry for production of new metals or materials. I mentioned on this channel before about Cislunar Industries, which has plans to establish a lunar metal foundry. Both GITAI and Cislunar were part of the DARPA study on lunar architecture systems, so could work together to produce lunar-sourced metals. One big problem with operating on the moon is dealing with moon dust. It's sharp, abrasive, electrostatically charged, and clogs up mechanical systems. The rover has a wireless charging system as a countermeasure to lunar dust. This has been tested in a regolith chamber and confirmed to work flawlessly. GITAI have developed a coated glass solution that effectively repels lunar dust, helping to keep the rover free from contamination. The ecosystem, competitors, partners, funding and supply chain. Robotic arms can be added to space stations, satellites or lunar rovers. GITAI is partnering with Toyota on Japan's pressurized lunar rover. As one of the selected companies in the DARPA study, its robotic rovers can help the other selected companies with their lunar architecture. For instance, Lockheed Martin's Lunar Rail Network could use GITAI rovers to help assemble and place track, sleepers, warehouses, power stations, and switching gear. Cislunar Industries could partner with GITAI to scavenge scrap metal or material to feed their lunar foundry. Any kind of logistics operation could benefit from the use of rovers, especially dual-arm robotic rovers supplied by GITAI. Funding is mostly from the Japanese government, the Japanese Space Agency, and many Japanese investment companies. Upcoming events. GITAI doesn't have any commercial missions yet. It will be launching a 500 kilo class spacecraft on a SpaceX Falcon 9 this month to test out in-orbit servicing tasks. A rendezvous and docking operation is planned for 2026 using its robotic arms. This is a key step to offering future on-orbit services to commercial customers. Expect a lunar infrastructure mission using its robotic rover to assemble a communications antenna on the surface of the moon. The company is in advanced talks with several US launch companies for a mission with potential funding from NASA or private ventures. There is some talk about lunar habitat construction mission, but nothing concrete yet. The Japanese pressurized lunar rover, complete with a GITAI robotic arm, is scheduled for launch sometime in the mid-2030s. GITAI seems well positioned for in-space servicing and lunar infrastructure missions. Leave your thoughts and opinions about GITAI in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Space News Live is on Saturday evening or Sunday morning, depending where you watch from. The live stream is a great way for you to share your thoughts and opinions on the videos I posted this week, or on any space topic in general. I highlight the most thought-provoking comments on videos I've received, along with previews of upcoming content. If you got the time, please tune in and say hi. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry, with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.